Good morning, everyone. Welcome back. Thank you for joining us. We are glad that you're here. I'm Steve,
And I'm Scott.
and together we're Backyard Musings, the Science and Technology channel.
Yeah, we're talking about a science space topic. We mutually love these topics, and this involves our favorite telescope, the James Webb Space Telescope. And it's talking about a rare alien, or possibly a rare alien world. So, very cool story here. So, here we go.
NASA's James Webb Space Telescope has uncovered a rare alien world that sits in a cosmic sweet spot between scorching hot Jupiters and frozen gas giants like Saturn. Astronomers using NASA's James Webb Space Telescope have examined the atmosphere of a rare giant planet with temperatures surprisingly close to those found on Earth. Not sure how they measure the temperature when it's that far away. The planet, called TOI 199b, is about the size of Saturn and contains methane in its atmosphere, according to a new study published in the Astronomical Journal on May 20th of this year. Would you like to know more?
The discovery is unusual because giant planets are typically found in extreme environments. In our solar system, Jupiter and Saturn are icy cold because they orbit far from the sun. Many giant planets discovered around other stars are hot Jupiters, which orbit extremely close to their stars and can heat up to thousands of degrees.
TOI 199b is different. Scientists classify it as a temperate giant planet, a category that includes only a small number of known worlds. Researchers say this is the first time the atmosphere of one of these milder giant planets has been studied in detail.
The findings could help researchers improve computer models that explain how planets and atmospheres form and change over time. The work may also provide new clues about atmospheric processes on Earth. The research was led by scientists from Penn State and NASA's Jet Propulsion Laboratory, Pasadena, California, at the California Institute of Technology. Oh, Caltech, yeah, okay.
Quote, one of the main advantages of studies of planets beyond our solar system, known as exoplanets, is the ability to study many different types of planets, especially ones that we don't see in our solar system, to learn about how planetary systems form and evolve, said Renyu Hu, associate professor of astronomy and astrophysics in the Penn State Eberly College of Science and leader of the research team. Continuing his quote, since the first exoplanet was discovered in 1992 by a team that included Alexander Wolszczan at Penn State, astronomers have found thousands of exoplanets, but only a few giant temperate exoplanets are known. And this is the first time that we have been able to study the atmosphere of one of them in detail.
I'll bet you that Renyu Hu is a pretty smart guy.
I bet you too, yeah.
Yeah. TOI 199b circles a star located more than 330 light years from Earth and completes an orbit about every 100 days. Its estimated temperature is around 175 degrees Fahrenheit, so that's not that hot, right? While that is extremely, well, it says it's hot, but I don't think that 175 degrees, that's
like an oven. It's like an oven.
Water heater, hot water coming out of a water heater is 140 degrees. That's anyway. While that's extremely hot by human standard, it is far less intense than the temperatures found on hot Jupiters. Researchers noted that similar temperatures can even occur inside cars parked in direct sunlight on Earth. So do not leave your animals and your children in your parked cars.
Right. It'd be like leaving them on the planet.
Yeah.
Okay. That makes TOI 199b much warmer than the frozen gas giants in our solar system, but far cooler than the superheated giant planets commonly studied around other stars.
To study the atmosphere of TOI 199b, astronomers used a method known as transmission spectroscopy. This technique measures how starlight changes as it passes through a planet's atmosphere during a transit. When the planet moves in from its star from the telescope's perspective.
James Webb Space Telescope separates incoming starlight into different wavelengths, similar to the way a prism splits white light into a rainbow. Quote, as a planet passes in front of its star, some of the star's light passes through the planet's atmosphere, where it interacts with the elements and molecules in the atmosphere, said Aaron Bello Arufe, a postdoctoral researcher at JPL and the first author of the paper. Continuing his quote, specific elements will absorb specific wavelengths of light, creating a fingerprint in the spectrum of light that JWST detects that reflects the atmosphere's composition.
Not to give credit where credit's due, but I'll bet you Aaron Bello Arufe is also a pretty smart guy. You think?
Yeah. Yes.
Yeah. I think to work at these places and do this kind of research, you got to be pretty smart.
Yep.
Researchers first recorded about 20 straight hours of observations to establish a baseline measurement from the star's light. The transit itself lasted around 7 hours, much longer than the shorter transits commonly seen for hot Jupiters.
And that makes sense, like, because Jupiter's so far out, it'd go quickly past the sun, you know, if you're observing way back here. But a star that's closer would take a little bit longer to get across. So that kind of makes sense to me. I'm not being funny about that. It makes sense. Scientists then compared the spectrum collected during the transit with the baseline observations. The differences revealed which wavelengths were absorbed by gases in the atmosphere, helping the team identify its chemical makeup.
Quote, when we compared the spectra during the transit to the baseline, we saw that the atmosphere blocked the wavelengths of starlight absorbed by methane. And that's according to Bello Arufe. Going on with this quote, models for the composition of temperate gas giant exoplanets had predicted that they would contain methane. So it is good to get confirmation that our theories are accurate. You want the money to keep coming in. That's
right. Give me your money. The observations also suggested that ammonia and carbon dioxide may be present in the atmosphere. Quote, with additional observation of this planet, we could establish the relative abundance of these various gases in its atmosphere, Hughes said. Continuous quote, this more complete picture of a temperate gas giant's atmosphere can then be used to improve our models and potentially better understand how planets and their atmospheres form and evolve, including for Earth. The success of this is continuing his quote here. The success of this first study of a temperate giant planet's atmosphere also gives us confidence to dedicate more resources and observation time to study other similar planets. We can see then if this planet is unique or if there are general shared characteristics for this type of planet. That was his confidence speech to get the money right there.
Yeah. Interesting story. Don't understand most of it, but pretty interesting. So there's guys out there that are doing this. I love it. So,
all right, folks. Thanks for joining us. We'll catch you in the morning.
Yeah. And continue safe travels on your way to Michigan.
Thanks.
Take care. Thanks, everyone.